In this video, we will discuss how to factor a quadratic. Now, quadratic expressions are of the form ax squared plus bx plus c, where a cannot equal 0 and b and c are real numbers. So in this situation, what makes this a quadratic is the fact that the largest exponent that you have in your expression is 2. We call that degree 2. So because this expression is degree 2, then it means that it is a quadratic. In this case, if you have all three terms, it's called a quadratic trinomial. Now, what we want to focus on is when a is equal to 1. So when you're factoring a quadratic when a is equal to 1, then you have x squared plus bx plus c. And here's the idea. You want to find factors of c whose sum is equal to b. And those factors will end up being the constants in your binomials. For these two problems, notice that the leading coefficient, or also the a, is 1 in each case, which makes it the same form that we were just discussing. So our c in this situation is going to be 30. And what I like to do is make what I call a factor sum table. I want to find the factors of 30, or my c. And the factors of 30 happen to be 30 times 1, also negative 30 times positive 1, negative 1. Okay, and as I do this, what I'm going to do is find the factors of those sums. So 30 plus 1 is 31. My goal is to get a sum of negative 11. Negative 30 plus negative 1 is negative 31. You can see that both of the factors need to be negative in order for my sum to be negative. So I'm going to focus only on negative factors. From here I can do negative 15 times negative 2, which is a sum of negative 17. I can do negative 6 times negative 5, which is a sum of negative 11. And we hit the jackpot here. We found the two factors whose sum is equal to negative 11. So what I'm going to do is write my parentheses for my binomials. I know the first two terms will be, the first terms in each binomial will be x, because x times x will produce x squared. I also know now that this will be a negative 6 and a negative 5. Now, one great way to check your solution, we know x times x is x squared. We know 6 times 5, negative 6 times negative 5 is positive 30. We know that. What we are checking and what we are trying to find up here with the factor sum table is finding a way to match the b. So doing the o and the I in FOIL will tell us whether we are correct. So x times negative 5 is negative 5x. Negative 6 times x is negative 6x. Combining those two will be negative 11x. So it does in fact check out. The second problem, I'm going to do the same process. I'm going to make my factor sum table. Again, I want to find factors of negative 28, and I want the sum to be positive 3. So right away I'm going to look for, let's say, how about 14 times 2? Now notice I need one of them to be negative. I'm going to choose the smaller number to be negative because I know my sum has to be positive. So 14 plus negative 2 is 12. Okay, close, getting there. 12 isn't too far away, but I need these two factors to be closer together. So I'm going to choose, how about 7 and 4? I think this will be correct, and I'm going to choose the 4 to be negative because I want my sum to be positive, and 4 is the smaller number. So 7 plus negative 4 is positive 3. All right, so I have my two factors now. I write out my binomials. I know this will be x and x in the first parts of my two binomials. I know now one of them will be positive 7 and the other will be negative 4. Again, I can go check, and I highly recommend that you do if this is something you're either learning or practicing for the first time or for the first time in a long time. But again, you're going to do the O and the I. You know the F and the L in FOIL, or in other words, the first and the last terms work out because that was the whole point of doing this process. Everything was based on the first and the last term. So negative 4x plus 7x, and so you get a positive 3x, and it does in fact check out. So we know that this is the correct answer.
You rascally rabbit.